So we are reaching our target of about 100 trigonometric identities, and here's another one for you. Sine square x plus 2 cos x minus 1 divided by sine square x plus 3 cos x minus 3 is equal to minus cos square x plus cos x divided by sine square x. Now these are level 2 questions and they're kind of tricky, right? So every question involves some strategy or the other. Now here what we will do is we will write sine square x as 1 minus cos square x. In that case, we'll get a quadratic equation in terms of cos, and then we'll factor the quadratic equation. So that is the strategy which we are going to follow here, right? So we'll factor a quadratic equation. So that is a strategy. Strategy is to form a quadratic equation, right? So and then factor it. Right? That is the strategy which we are going to follow. So sine square x can be written as 1 minus cos square x. Is that okay? Many times students don't really use the formulas in the right way. You know, the formula trigonometric Pythagorean identity is sine square x plus cos square x equals to 1. This should be seen in three different equations. One is this one, the other one is sine square x is equals to 1 minus cos square x. Remember that. And cos square x is equals to 1 minus sine square x, right? In fact, this is one of the most important identities which you are working with, because this can be further written. 1 minus sine square x can be factored, right? And 1 minus sine square x can be written as what? 1 plus sine x times 1 minus sine x. Similarly, 1 minus cos square x can be written as 1 plus cos x times 1 minus sine x. 50% of the trigonometric problems are solved just using these. Okay, remember that. Now here, let's continue with our formation of quadratic equation and then factoring, right? So the first step is we break sine square x as 1 minus cos square x plus 2 cos x minus 1 divided by 1 minus cos square x plus 3 cos x minus 3. So we have started with the left side, right? So we are starting with the left side, and let's see what happens. Okay. So left side is equal to this, and now we have a quadratic equation, correct? 1 minus 1 is 0, so I have minus cos square x plus 2 cos x in the numerator, correct? So which I can factor, correct? So let me first write minus cos square x plus 2 cos x, since 1 minus 1 is 0, right? And the denominator gives us minus cos square x plus 3 cos x. Minus 3 and plus 1 gives us minus 2, right? Now let's factor numerator and denominator. So we can take minus cos x common, and so we get minus cos x. We are left with cos x here minus 2, correct? We took minus cos x common. And here we need numbers whose product is minus 2 and sum is plus 3. Well, everything is negative outside, so we'll do negative of that. So let me first take negative of that, and then we'll factor it. So it could be factored as cos x minus 2 times cos x minus 1. Correct? So when I multiply this, you see, minus 2 times minus 1 is plus 2, but that minus makes it negative. Do you understand? That is what it is. Cos x times cos x is cos square x, but this makes it negative cos square x. So we get this term. And the middle term will be, there is 1 cos x, which is cos x times minus 1. And then we got 2 cos x when we multiply minus 2 with cos x, correct? And those negative numbers gets multiplied by negative to make plus 3. So that is the factored form of our equation, right? Now here you can see cos x minus 2 is common, and therefore it can be cancelled out, right? So we can write this as plus minus and minus will also be cancelled out. So we are left with cos x in the numerator divided by cos x minus 1. But we need that complicated structure here, right? Do you see that? So what we cancelled is we cancelled out this negative sign and we cancelled out this term, correct? And we are left with cos x over cos x minus 1. But look at what we need to do. We need sine square x in the denominator. Now, as I was working through all these, you will see that 1 minus cos square x is sine square x. I have cos x minus 1. So what I should do here is, see a strategy which I am doing. I'm multiplying this with cos x plus 1 and dividing by cos x plus 1. So cos x plus 1 in both numerator and denominator, correct? It as good as multiplying by 1. Now if I do so, I get cos x times cos x plus 1. If I multiply, I get cos square x. Do you see that? And cos x plus 1 is plus cos x divided by, this is a minus b times a plus b, that means a square minus b square. So I get cos x, cos square x minus 1. Correct? Now let's go here. So we have cos square x plus 1 in the numerator, which we want. We don't have negative sign yet, but we'll soon get it. So we get cos square x plus cos x in the numerator divided by cos square x minus 1. But cos square x minus 1 should be minus sine square x, right? Sine square x is 1 minus cos square x. Do you see that? So this is minus of sine square x. So that gives us the right hand side, which is minus cos square x plus cos x divided by sine square x. Do you see that minus sign? And that is how we prove our identity, correct? So you see how beautifully we rationalized here. So at this stage, we call this rationalization, okay? So this stage is called rationalization. And here we use the formula difference of squares, right? A square minus b square is a minus b times a plus b, correct? And we use difference of squares here, which is, we can say a minus b times a plus b is equals to a square minus b square to get that stuff, right? And here it is 1 minus cos square x, which is sine square x, but we want cos square x minus 1, so we take minus both sides, so it becomes cos square x minus 1. Do you see how beautifully this has been proved? Thank you.